Hello my dear students, good morning. Now we will discuss about this preparation of hydrogen by using this process, Bosch process. Okay. What we use here, very simple. Carbon we will treat with water actually. Okay. In presence of nickel at 1000 degrees Celsius. Okay. Then you will get carbon monoxide plus H2. What is this? Carbon monoxide plus H2. Carbon monoxide plus H2 is called syngas. Syngas or else water gas we call. CO plus H2. Syngas it is. Okay. So here you have H2. So this H2 you can increase, you can improve the quantity of hydrogen by how this carbon monoxide when react with water again, then what happens, sir? In presence of course again here also we have to heat in presence of catalyst like Cr2O3 or else Fe2O3 we have used, and 673 Kelvin temperature we have used. Then what happened here? CO2 plus H2. So how increased? The CO again automatically will react with water. Certainly more amount of hydrogen gas will liberate. This is one of the preparation of hydrogen actually. So hydrogen preparations already few we learned. Now if you see its a physical property, it's very simple. H2 is a gas. It's a single bond H, single bond H. Bond energy is very high. Bond energy is very high actually. Comparatively, remaining all sigma bonded single bonds, if you consider H single bond H bond energy is more. Its dissociation energy is very much high. Almost to dissociate around 1800 degrees Celsius is required. Means almost 2000 degrees Celsius is required to dissociate H single bond H. But however, hydrogen will form two types of hydrides actually. So ionic hydrides and covalent hydrides. This how we will classify these hydrides as covalent hydrides. What is the covalent hydride and ionic hydride? Ionic hydride. Of course, few covalent hydrides, again two types. One is polar covalent and non-polar covalent, as of we know. See, covalent hydrides, how they form actually? Non-metal when react with hydrogen, like chlorine when react with hydrogen, like that. If you have, see, like HF, okay, HCl, even NH3, like this. This is all what we call covalent hydrides. What the hydrides called? Covalent hydrides they are actually. So here H plus and F minus, H plus Cl minus, nitrogen actually, nitrogen minus 3 because 3 hydrogens are there, each hydrogen minus 1, so 3 hydrogens minus 3, sorry 3 hydrogens plus 3, sorry with non-metal no, sorry 3 hydrogens plus 3 and nitrogen minus 3. Got it sir everyone? So here nitrogen has a minus 3 and each hydrogen is a plus 1. Each hydrogen is plus 1 there. Do you know the electronegativities of atoms? So that you only can say charges. See, ionic hydrides, how you will get, like as of you know sodium hydride, MgH2, like this and so on like this. Okay, why this is ionic? Because here Na plus and here H minus. But here, sir, here also you have charges, no sir, but these charges are like this. HF is like this. So you have F delta minus and hydrogen delta plus. These are the partial charges due to unequal sharing of this covalent bond. So this covalent bond actually shared between hydrogen and fluorine like that. So due to more electronegativity, this fluorine got partial negative charge, this hydrogen got partial positive charge. This is a covalent bond, means 2 electrons shared between hydrogen and fluorine but not equally. That particular pair shared unequally. Got it sir clearly? And here also you can have what exactly happens. So here Na plus means from sodium 1 electron transferred, means Na plus 1 electron is converted to Na plus, and H will take 1 electron and convert it to H minus. So what happened here? 1 electron completely transferred from sodium to hydrogen. So between sodium and hydrogen, complete transfer of electron taken place, but between hydrogen and fluorine there is no transformation of electron. They contribute one electron and sharing. Then why you are talking about all this nonsense? You are thinking like that? No. Actually what I am saying, these hydrides are what kind, they'll ask you, which are covalent, which is more covalent, which is less covalent, which is more ionic, like that they will ask you questions. Then how we will decide, sir? From the electronegativity values. If the electronegativity difference increases, then ionic nature increases, covalent nature decreases. Who is more covalent means who is more non-polar, remember this one. So when the electronegativity difference between two atoms decreased, suddenly that is more covalent, you have to say. Which two atoms? The bonded atoms. Got it clearly? So this is very important. And actually hydrogen reactivity even in halogens also we will see with the fluorine and chlorine and bromine and iodine. If you see who is more reactive means fluorine is more reactive than chlorine, chlorine is more reactive than bromine, bromine is more reactive than iodine actually. That means H2 when react with F2, this reaction even takes place in dark because fluorine is a very small and more electronegative, not more, most electronegative. So F single bond F dissociation energy is very less. So F single bond F bond can easily break. So F minus can easily initiate for the breaking of H single bond H. Certainly you will have 2 moles of HF. Like this happen. So H2 plus Cl2, if you see some sunlight is required. Okay, then here you have 2 moles of HCl. So which reaction is fast? This is fast, too much fast, because the reaction happening in dark itself. So fluorine is highest electronegative, certainly this is a more reactive, so hydrogen can easily combine with fluorine. Correct? So in that way you have different kinds of hydrides. Okay. Next we have most important topic, that is uh, heavy water instead. Heavy water we will discuss later, and before that we will discuss hardness of water. So first water and then heavy water. Better to go one by one actually. Okay, sir. So if you see what is hardness of water? Hardness of water. What is the hardness of water? Actually, this you can understand by having one example. See, if you are taking bath by using seawater, then even you apply soap, you won't get good leather. Okay, foam like that you will get, that won't you will that you won't get actually. Then water is harder because in that sea water you have some salts which causes hardness. Okay, so what is the hardness means? The substances due to some kind of salts of calcium and magnesium, they won't give good lather, they won't form lather on your body, you can say. So what you can say then? Okay, that is hard water, that's called hardness of water simply. So what is the hardness of water, you understood? So due to presence of some salts. Okay, what salts I'll tell you, don't worry. Salts of Mr. calcium and magnesium, due to that if you apply soap you won't get lather, then that water is called hard water, and that phenomenon is called hardness of water. This is very important. So soap you will apply, then you won't get like foam. then that water is hard water. If you take bath by using river water, like you will get a foam. That hard water is, sorry, river water is soft water. Okay, what we drink, soft water. Okay, so sea water, that is hard water. Hardness causes what? Which salts will causes hardness means I'll tell you now. Okay, so this hardness of water, two types actually. One is temporary hardness, and one more permanent hardness. So permanent, okay, permanent hardness, two types. So when temporary hardness happen, very simple. Temporary hardness is due to presence of due to presence of, okay, bicarbonates. What's a bicarbonates or hydrogen carbonate, you can say bicarbonates of Mr. calcium and magnesium, excuse me. Okay, so which causes temporary hardness means the bicarbonates of calcium and magnesium causing what temporary hardness. Okay, example, what is the formula of those salts which causes temporary hardness? I am writing here. So MgHCO3 whole twice, okay, or else what, and CaHCO3 whole twice. These two salts are causing the particular temporary hardness. So temporary hardness, why we call, we can easily remove. Okay, permanent hardness also we can remove from water, but it takes time. It takes more time. So there is more procedure for removal of this permanent hardness. Okay, so what causes temporary hardness means bicarbonates of calcium and magnesium. This is magnesium bicarbonate, otherwise magnesium hydrogen carbonate. This is calcium bicarbonate or calcium hydrogen carbonate. Why I'm saying two names? Because in options they will give names. That's very important. Which causes temporary hardness? Then they will give these names actually instead of formulas. So you must know all those things. And come to permanent hardness. Which causes permanent hardness means permanent hardness is presence of due to presence of what we call the sulfates. What's that? Sulfates and chlorides. Sulfates and chlorides of same calcium and magnesium means which causes permanent hardness. You can say like excuse me, MgCl2 CaCl, chlorides of magnesium and calcium. And what causes sulfates? Sulfate formula you know na? Magnesium sulfate, MgSO4 and CaSO4, calcium sulfate. So these are causing permanent hardness. Means we have now a clear idea which causing temporary hardness, which causing permanent hardness. What is the difference between temporary hardness and permanent hardness? Understood? Temporary hardness can easily remove. Okay, and permanent hardness, it's not easy to remove. Understood? Now how to remove this hardness? How to remove hard water into soft water? That means how to remove these magnesium and calcium bicarbonates, how to remove these chlorides and sulfates of both magnesium and calcium, we have to see. Means we are removing these salts from water, means we are making hard water into soft water. What is the difference between hard water and soft water? With soap who give good lather, that is called soft water. who won't give that foam and all with soap. That is hard water. Simple thing. Okay. So hardness, how we will decide? Just by using soap. Okay. Next, what are the things we have to remember to remove temporary hardness and permanent hardness? We have to see now. So methods to remove temporary hardness. First, temporary hardness. So as I told you, temporary hardness we can easily remove temporary hardness by how? Means the first process is a simple boiling process. Boiling of hard water. Boiling of hard water is one of the simple way. First we will decide, or we will, you can check actually what salts are present actually. If bicarbonates are there, okay, you found that bicarbonates are there. Simple boiling you can have, okay, that soft water. Otherwise, we only will normally check. First, we will boil, and after boiling, don't pour on you. Okay. So after cooling, again, if you pour on you, or if you apply soap on cloth or something else, okay, on cloth you pour water, and you are applying soap, you are getting that good what we call lather or foam, so that the water converted into soft. Understanding? Suppose you are washing clothes, okay, so you are using detergent, and if that is giving good foam, that is soft water. In that way you can find out. Okay, so by simple boiling of a hard water, you can convert hard water into soft water. Like what? So what I said, bicarbonates you have. So simply I'll write MHCO3 whole twice. What is M here? M is either magnesium or calcium. Why to write two times? Same reaction, no? So when you are heating this simple boiling, then what you will get? This M2CO3 plus H2O. M2CO3 2 moles and CO2 like this. Carbonate won't cause any hardness. Bicarbonate causes. So bicarbonate, while heating, the particular bicarbonate who is present in water, I written aqueous. So this bicarbonate who is present in water on heating, that converts to carbonate. In that way, that bicarbonate removed. So this M2CO3 is a precipitate actually that will deposit. It cannot dissolve in water. Actually, this is a dissolved form actually. We can't see. Okay, so this on heating, this M2CO3 you will have. Understanding, sir? Many times maybe you saw at home while boiling water, okay, in a particular vessel. If you see after boiling for certain temperature like 100 degrees or 200 degrees like that, after some heating, if you observe, after cooling if you observe, on the walls of that vessel you will get a white color powder, you can observe. Okay, that means what? This kind of carbonates are forming. So that water what you boil is hard water. Got it, sir? So that is temporary hardness or permanent hardness. Again, you can test that after boiling. You can test that water. How? By applying soap. Simple way. Okay. So this is the boiling, and the second one is what we call treating with lime water. What is lime water? I was given already. Calcium hydroxide, CaOH twice. What is this? CaOH twice. So calcium hydroxide when treated with means when reacted with that particular hard water, then that particular what happens? That hardness will remove. So calcium hydroxide, suppose this MHCO3. M means what? Suppose here you have HCO3 whole twice. When react with this CaOH twice, same story. What happened here? CaCO3 will form. CaCO3 will form. and of course 2 moles here will come. So how many moles, don't ask me please. And along with that, and you will have H2O plus CO2 like this. Even magnesium, MgCO3 will come here, same reaction. Got it, sir, everyone? So very simple. Yeah, 2 moles are written, so no need of this CO2. Got it, sir, everyone? So this is a very important thing. So if you see magnesium here, magnesium bicarbonate with calcium hydroxide. What do you have? 2 moles of magnesium carbonate, calcium carbonate and water you will have. Want reaction? I will write. Instead of this particular CaHCO3, I will take MgHCO3 whole twice when react with Mr. This particular CaOH twice. Here you have 2 moles of calcium carbonate because both are calcium only. But here you have MgCO3 plus CaCO3 plus H2O you will have. How many moles you please decide? But it's here 2 and here 2. 2 moles of water. Don't be hesitate. Oh, man, don't worry about that number of moles of water. How that is converting. See this particular aqueous. Why I am writing aqueous? This particular bicarbonate is present in hard water. So you are taking hard water and in that hard water you are pouring this calcium hydroxide, which is called lime water. So then automatically this calcium bicarbonate is removing as calcium carbonate precipitate like this. Certainly these are what we call cannot be dissolved in water, this calcium carbonate and magnesium carbonate. So they can be separated by filtration. So after precipitation, after filtration, you have a remaining water which became soft. Okay. So these are the two methods to remove temporary hardness. Now we have to remove permanent hardness. Actually one more is there, by treating with sodium hydroxide or by treating with sodium chloride or by treating with sodium carbonate, then also temporary hardness can be removed. What I am saying, understanding? With water, if you treat with water, if you are treating sodium carbonate, washing soda, NaCl and NaOH, otherwise if you use, then you can remove this temporary hardness. But by using these three substances, means by using sodium carbonate and sodium chloride and Mr. NaOH, all three not required, any one. If you add to water, then you can remove permanent hardness also. But that is not much effective. This is you have to remember. So why I am telling all these things, not for time wasting. They'll ask you which will remove both temporary hardness and permanent hardness. They will ask you. Then you have to select option like sodium carbonate, either sodium carbonate or NaCl or NaOH. Okay. So what we discussed, methods to remove temporary hardness. Now methods to remove what hardness? Permanent hardness now. So as I told you, first treating with sodium carbonate, washing soda. Okay. So permanent hardness, how to remove? So first method is treating with or heating with, you can say, washing soda. Washing soda, Na2CO3. Decahydrated sodium carbonate, no, that we will add to water. Or else you can add NaCl, or else you can add NaOH like this. So what causes permanent hardness? I told you already, permanent hardness is due to this MCl2 or magnesium, you can write directly, MCl2 and Mr. MSO4. What is M there? M is either calcium or magnesium. Okay. Now you have to remove this M, okay, from water, calcium, and if you deposit those particular salts, then that hardness can be removed. So what causes, suppose I write calcium chloride, when react with Mr. NaCl, what happens? on heating. Certainly 2 moles required. Na2CO3 suppose, sorry. Na2CO3 if you are using. What happened? 2 moles of NaCl. Okay. And you have Mr. remaining. What is that? CaCO3. Both are salts which can be deposited. Actually, NaCl salt that also causes hardness somewhat, but very less. So when compared with calcium chloride, NaCl causes very less hardness. That's why if NaCl is there, hardness will be there. No, sir. Somewhat means yes. That's why this process is not effective. Understanding what I am saying? So you are removing this particular calcium chloride in this form. Alright, sir. So this is treating with washing soda. Second one is treating with or react with, you can say, treating with. I said NaCl also, no? NaCl, NaOH, that also you can use. Okay, treating with some complex Na2, Na4, PO3 whole 6 times. Okay, Na6, or else you can write like this: Na6, P6O18. This is called, this particular compound name is chalcone. Okay, chalcone, very very important. Chalcone is the substance, is a complex. Okay, so it's a complex, it's complex, IUPAC name, everything, complex compounds you have chapter. So this particular chalcone we will add to hard water. Then what happened? The sodium what you have outside, that will be replaced by calcium or magnesium. Understanding what I am saying? So this what the substance which you have in a bracket, that cannot be dissociable. So this is completely covalent, which is present in a bracket. Outside what you have, that can be ionizable. So when you are treating with this MCl2 or MSO4, MCl2 with particular this chalcone. What is chalcone? Na2, Na4 and PO3 6 times, or this MSO4. What is M? I said many times. This is calcium or else magnesium. So if you see this MSO4 when treated with Na2 and Na4, PO3 6 times, what happens now? Very simple. Here this sodium is there, but sodium replaced by this M. What is M? In place of M, what you can write? Calcium you can write, or else magnesium you can write. Now what you will have? This M and Na4, this PO3 6 times, and 2 Na plus and 2 Cl minus. That means 2 moles of NaCl you are having. 2 moles of NaCl you are having. And now this M, same story. M, Na4 and PO3 6 times, and Na2SO4, sodium sulfate. So this present, okay, and in this present in water, no sir. Is it present as a precipitate? No, this is dissolved in water particularly. Okay, but when you treat this particular hard water with this chalcone, then this will deposit actually. So these are actually dissolved state, and they depositing. This M we are removing. So this is one more. So this is a chalcone process to remove permanent hardness. What is chalcone? Chalcone is Na2, Na4, PO3 6 times. Okay, it's IUPAC name. If come in exam, you can write like this: first cationic part, but don't write di, simply sodium. Okay, sodium hexa phosphato, because when anion is there, hexaphosphato, and sodium again, because both are sodium only, but here sodium oxidation state you have to mention, that is one. So important, you have to remember Calagon and Calagon formula, and when Calagon added to hard water, what happens? I was given. So in our next class, we have two more methods, that is ion exchange method, not two, just one only. Okay, so that is the zeolite process or permanent process we call, and ion exchange process we have. Okay, so both we will discuss, and we will finish that hydrogen peroxide also.